Good morning, good afternoon, good evening, depending on where you are watching me from. In this video, we'll be looking at topic Taylor series method for simultaneous first order differential equations. One of the examples says, using Taylor series method, obtain the solution of the given simultaneous differential equations. We have here dy over dx equals to z minus x, and the z all over dx is equals to y plus x. Take h equals to 0.1, compute y of 0.2 and z of 0.2, where z naught is equals to 1 and y naught is equals to 1. Yes, simple as ABC. What I want you to do for me is make sure you share this video. Let this video should go viral. Amen. Make sure you like it, comment on it. We are here to learn. If there is any question, drop it on the comment section. I will look at it together with you. Amen. Make sure you follow me on my YouTube, my Facebook, or go to Google, type on this, Google this Rainjog Maths. I think if you Google this, Google is going to show you a lot of things in mathematics. I solved past questions, university past mathematics questions, year 1, year 2, up to final year, engineering mathematics also, not only engineering mathematics, science mathematics, not only science, business mathematics. In fact, all the mathematics, you will see solutions. Please don't forget to share this. And follow me on my Facebook page. Type this, you will also see me on Facebook. Thank you and God bless you. I love you all. Okay, let's solve this idiot. It's simple as ABC. Forget about the grammar they are speaking. I'm going to take it step by step. Make sure you understand this. You know, in the first video, my first video on this, I solved similar problem, but not simultaneous. It's just a single differential equation. Yes, today I'll be looking at two differential equations. It means that if you know it very well, don't be scared with the name simultaneous. Go back to your secondary school. I think you started solving simultaneous equations from GS2, if I'm not mistaken, GS2, GS3, up to SS3. It's like that, but here is more advanced. So I'm going to break it down for you. So don't be scared. Amen? Okay. So now, before we consider this, I will take course. Let us go back to calculus. You know, if you don't know calculus, it will be difficult for you to look at problems of this kind. Amen? But let me just refresh your memory so that when we are working or solving this problem, you won't find it difficult. Amen? It's okay. So if you agree with me, let's consider what it means by implicit function. Implicit function or functions, whichever way. Okay, you know, implicit functions are of this form: x, y squared, or x squared y, or sometimes you will see 2x y squared. These are implicit functions. Do you agree with me? Or sometimes you may even see something of this form. this and this equals to, let's just say, 2y or 2x, or you will see x squared. These are implicit functions. Amen. I know very well that with me, I don't think you'll find it difficult to solve this kind of problem. Please just follow me always. Make sure you share this video. Thank you. It's okay. So now, these are implicit functions. What they will just say, given this, amen, given this, they will just say find the y all over the x. Because we are using this approach to solve this problem. Is that clear? Okay. So I want us to have idea on this before we proceed. Okay. What we are going to do, let's write solution first. Our 2x square y square is equals to x square. So if we are to find the y over the x, what we need to do is, let us use this method, d all over dx, 2x y x is equals to d all over dx, open bracket, x squared. Amen? So if you agree with me, I'm going to break it down for you. This implies that this thing means differentiate what is inside here. The same thing applicable here. But here we have two functions. Do you agree with me? We have x and y, isn't it? So it means we are going to differentiate these functions implicitly. Just like, you know, implicit functions is more like product rule, if you agree with me, two of us. So what we are going to do here is we are going to since there are two functions and they have constant 2, either we hold this one, differentiate this one, or we hold this y square, then differentiate 2x squared. Which one do you want us to do? Okay, we hold y square, differentiate. Okay, if we hold y square, differentiate 2x squared, we are going to have 4x dx all over dx. Sorry, let us not rush. 4x, isn't it? Now use it to multiply the constant we hold, y squared. So it means we are going to have 4xy squared, the what? The x all over the x. Mind you, there was nothing here, but now we have x here, isn't it? This means that you differentiated for what? X. That is why you are seeing x. Then plus the same thing applicable here. We are going to hold 2x squared, then differentiate y squared. So if we differentiate y squared, we are going to have 2y. Then use it to multiply 2x squared. We will have 4x squared y the what? Dy, isn't it? All over the x. Why? Because this means we differentiated for what? Y. So this is equals to the same thing applicable here. 2x, x squared. If we differentiate x squared, we are going to have 2x dx all over what? The x. Do you agree with me? So if you can see what I am saying, dx all over dx is the same thing as 1. 1 times this is 4xy squared, two of us, plus 4x squared y dy all over dx is equals to 2x, because this and this is the same thing as 1. So we collect like terms. If we collect like terms, the left hand side will now be 4x square, but okay, but for the sake of manias, 4x square y dy all over the x is equals to 2x. This crosses the sign of quantity, becomes minus 4xy squared. Amen? So now they say we should find the y over the x. I'm doing this because of this problem that I want to solve, so that you won't be stranded along the line. So now they say we should find the y over the x. So how can we find the y over the x? For us to divide 2 by 4x square y. So if we do that, we are going to have the y all over the x is equals to 2x minus 4x y square all over this idiot 4x square y, isn't it? So you can leave the answer this way, or if you can see what I am saying, this is the same thing as the y all over the x, the same thing as 2x all over 4x square y minus 4x y square all over 4x square y, isn't it? So our dy all over the x is equals to this, we are going to have 1 all over 2xy, isn't it? Minus this to this, we will have y, isn't it? We are going to have y all over x. I think this is the final answer, because this cancel this cancel this, then this cancel this. This is what we are going to have. I think this is the final answer. So this is how to differentiate implicit function. So now let's go back to our business for the day. So can I clean this? Let me clean this. Okay? Okay. Make sure you share this video, subscribe to my YouTube channel, follow me on Facebook, as I told you. Okay. So now we want to solve this problem. You know, before we solve this problem, I'm going to explain a lot of things here. Take h equals to 0.1, compute y of 0.2. You know, in differential equation, sometimes they present this f of z, f of x, sorry, equals to 0. If this f of, y of x equals to 0, this means y, if y is n and x2 is n, where n is equals to 0, y naught and x naught equals to 0. It means our y naught is equals to 0, x naught is equals to 0, isn't it? So please take note, I want to explain something for you to know and understand. So now our y of 2 means y of 2 means that is our x is that is either x1 is equals to 0.1, then x2 is equals to 0.2. So supposing our y of 0.3, this implies that x1 is equals to 0.1, x2 is equals to 0.2, x3 is equals to 0.3. I'm explaining this because we are going to make use of all this well substituting. Okay, so the same thing applicable, z of x. So this implies that equals to 0, this implies the same thing. So now we have z of 0.2. It implies that our x1 is equal to 0.1, then our x2 is 0.2, because y and x are dependent variable and x is independent. So take note. So now let's look at it together. Like here, y of naught is equals to, this implies that if you have y of 0 equals to 1, it implies that our y is 1, then our x is what? 0. That's the meaning. So please take note. Take note. Okay, can I claim? Okay, so now let's solve this idiot together. Let's solve it together. Amen? It's simple as ABC. Life of mathematics is always beautiful with Mr. OSI. Okay, now our dy all over the x is equals to z minus x, and our dz all over dx is equals to y plus x, isn't it? Okay, now, you know, in the other video I said if we have dy all over dx, this is the same thing as y prime, isn't it? Likewise, if we have dz all over dx, this is the same thing as z prime. So what if we have d square y all over dx square, this is the same thing as y prime prime. Then the same thing applicable, sorry, d square z all over dx square is the same thing as z prime prime. Then d cube y all over dz dx cube is the same thing as y prime prime prime. Then d cube z all over the s cube is the same thing as z prime prime prime. Please take note. So if you agree with me, it means we are going to transform this left hand side this way. Our y prime is equals to z minus x. Let us label y prime n, z n, z x subscript n. The same thing applicable here. Our the z all over the x is the same thing as z prime, which is y subscript n plus x subscript n. Okay? So now it means we are going to differentiate this, we will differentiate this. So let us differentiate this. If we differentiate y prime, our y prime is going to give us y prime prime. Take note. So y prime prime n subscript n is equals to, if we differentiate z, is going to give us what? Talk now. Is going to give us sorry, z prime, isn't it? Z prime. Then differentiate x is going to give us what? 1 minus 1, isn't it? Okay. Then let's differentiate this z prime will give us z prime prime. Then we differentiate y, we are going to have y prime plus if we differentiate x, is going to give us, make sure write this thing, is going to give us what? 1, isn't it? I know you are confused a little bit because of this. You know, I told you that we are differentiating with respect to what? X. So this will be what? 1. Why this one will be prime? So please take note. Here, the same thing applicable here. We are differentiating with respect to x. So here will be 1. If you differentiate x, it's going to give us 1. If you differentiate y, it's going to give us y prime. Okay, so now let's move down to differentiate y prime prime. If we differentiate y prime prime, it's going to give us y prime prime subscript n. Then differentiate this, is going to give us z prime prime subscript n. Differentiate 1 is going to be 0. Then the same thing applicable here. Z prime 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 equals to differentiate this. Let's differentiate y prime is going to give us y prime prime subscript. If we differentiate 1 is going to give us 0. Then let us differentiate y prime prime. If differentiate y prime prime is going to give us IV subscript n. Y prime is going to give us y prime prime subscript n. Sorry, z prime is going to give us z prime prime. Then please don't forget to put subscript n. Then z prime 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 IV subscript n. Y prime prime is going to give us y prime prime subscript n. Then if we differentiate y IV, is going to give us v subscript z prime prime is going to give us IV subscript n. The same thing applicable here. Z IV, we differentiate it, will give us ZV is equals to YIV subscript n. Okay, so now we are going to look at it together here, as simple as ABC. Yes, you can take this part, right? You know, our Taylor series, we know that y is equals to z if we are in talking about x. Here is supposed to be x minus x naught y prime all over 1 factorial plus x minus x prime x naught, sorry, y prime prime, mind you this is n all over what? 2 factorial plus da da da, isn't it? But here we are not here it said take h as what? 0. What? 1. So for that reason the formula is going to be y subscript 1 n plus 1 is equals to y subscript n plus h of x n y prime 1 all over 1 factorial plus h x n y prime prime n all over 2 factorial plus da da da. This is the formula we are going to use. Then when we come to z, since there is a simultaneous differential equation, so z2 will now be zn subscript 1 is equals to zn plus h xn, because all of them contain x naught, x1 up to x2, true of us. So you must put xn when when n is equals to 1. Y, sorry, z prime, since we are talking about z prime all over 1 factorial plus h x n z prime prime zn plus da 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 all over 2 factorial. So take note of this formula. This is what we are going to use. We are not going to use this one. I know some of you will ask, why not this one? But mind you, because of the condition given, we are using these two formulas to obtain the solution. Okay, thank you. So now, at this point, I can take this, right? At this point, what we need to do here is to obtain our y prime. It implies that z prime up to y v and zv. Now, how can we obtain them? Is if our n is equals to what? 0, it implies that we are going to have y prime naught is equals to z naught minus x naught, isn't it? So our y prime naught is equals to, what is our z naught? Our z naught is this, isn't it? Our z naught is this. Two of us, I told you before we started solving. I said if it's supposed to be this form, but for the fact that z of 0 is equals to 1, it means our z naught is equals to 1, while our x here is what? Is 0. That's the meaning of this statement. Is that clear? Please take note. So we are going to substitute in this 1 minus x naught, sorry, x naught is what? 0. So this is equals to 1. So this implies that y prime naught is equals to 1 Then let's consider z prime naught. If n is 0, it implies that our z prime, okay, let's do it this way. Since we are solving it simultaneously, let's do it this way. Our z prime naught is equals to y naught plus x naught, isn't it? Then our z prime naught will now be, what is our y naught? Our y naught is, I told you, look at it, it's given as y of z, 0 is equals to 1. So this implies this is the same as yx, isn't it? Yx is equals to 1. That is, it means our y naught is 1. Then our x naught is what? 0. Take note. Is that clear? Please take note of all these things. So our y naught is what? 1 plus x naught already 0. So our z prime naught is equal to 1. Then let's move to y prime naught. Y prime naught is equals to z prime naught minus 1. So y prime naught is equals to z prime naught is what? 1 minus 1. It means this is equals to 0. So our y prime naught is 0. Then z prime naught is equals to y prime naught, isn't it? Plus what? 1. So our z prime naught is equals to y prime naught is what? Come back here, is 1. 1 plus 1, which is equals to 2. So take note. Then y prime naught is equals to z prime naught. What is z prime? Z prime is 2. Then z prime naught is equals to y prime naught. What is y prime naught? Is 0. 0. Then y iv naught is equals to z prime naught. What is z prime naught? Z prime naught is 0, isn't it? Then z iv naught is equals to what? Y prime naught. What is y prime naught? Is 2, equals to 2. Then yv naught is equals to what? Ziv naught, this is ziv naught is 2. Then zv naught is equals to yiv naught. Our yiv naught is what? 0. So please take note. Do you agree with me? Do you agree with me? Okay. So now we want to let's look at our Taylor series in the form for y1, isn't it? So if, let's write out the Taylor series for y and z. So if you agree with me, our Taylor series will now be y subscript n plus 1 equals to yn plus, I told you we are going to use h of xn y1 all over 1 factorial plus h of xn y prime n all over 2 factorial plus h of n h of xn y prime n all over 3 factorial plus da da da. So that is for y. So if n is equals to 0, it means if you substitute in 0 here, we are going to have 0 plus 1, which is 1. So our y1 is now equals to, when you substitute in 0, we are going to have y naught here plus hx naught times y prime naught all over 1 factorial, this is factorial, plus hx naught y prime prime naught all over what? 2 factorial plus hx naught y prime 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 naught all over what? 3 factorial plus da da da. Do you agree with me? So now, can I clean this? I can clean this, right? Okay. So if you agree with me, or I should clean this up, let me clean this up. If you agree with me, because I will make use of this. If you agree with me, this implies that our y1 will now, what is our x naught? X naught here is 1, isn't it? 1 plus, what is our h? Our h is given as 0. What? 0.1, then x naught is what? 0, isn't it? Times 0, the y prime naught is 1 times 1 all over 1 factorial plus the same thing applicable plus h is 0. Then x naught is what? 0 all over 2 factorial times our y prime prime naught. Our y prime prime naught is 0, isn't it? Times 0 plus the same thing applicable here. Amen. You agree with me? The same thing applicable here. Our h is what? H is 0.1 times x naught is 0. Then y prime prime is 2, isn't it? Times 2 all over 3 factorial plus you can see that our y prime, y1 is equals to what? 1. How? Because use 0 to multiply 0 of this is 0. Divide this, 0. The same thing applicable 0, and the same thing applicable here, 0. If you divide this, then this continues. So our y1 is equals to 1. Then let's consider z. Is that clear? The Taylor series for z will now be equals to, we are going to change this. We will change this, amen. Just for us to, instead of y, we change it to what? Z. Anywhere we see y, z, n, then this is z, n. This is z prime, n, amen. This is z prime prime, n. This is z prime prime prime, n. Then it continues. So when n is equals to 0, it means we are going to have z1 equals to z0, amen, z0 plus plus h all over x0 z prime naught all over 1 factorial plus h z x naught z prime prime naught all over 2 factorial plus h x naught 3 factorial z prime 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 naught plus da da da. Is that clear? So let us obtain our z one. For us to obtain our z1, our Z1 will now be equals to Z0 is what? Z0. Our Z0, look at it here. Z0 is 1, isn't it? 1 plus, what is our H? Our H is given as 0.1, mind you. Then S0 is always 0. Then Z prime naught, look at it here, is 1 all over 1 factorial plus H is always 0.1 given as X0 is 0 times Z0 prime prime. Z0 prime prime is 2 times 2 all over what? 2 factorial plus H is 0.1 times X0 is 0. Then Z prime prime, Z0 prime prime, Z0 prime prime is 0 all over 3 factorials plus da da da. So you discover that our Z1 is also equals to 1. True or false? Do you agree with me? Okay. So now we are done with X1 as 1, Z1 as what? 1. Now, they said we should compute Y of 0.2. It means our X will now be when X is equal, when N is equals to 1. It means our X1 will now be 0.1. And okay, so it means we are going to have this when okay, where can, because we are going to, we need all these things. Okay, let me clean here. Let me clean here. Let me clean here. If I clean here, it means when N equals to 1, it means all these ones will still come back to them. When N equals to 1, it means here, look at it. When N equals to 1, it means here will be what? 1, isn't it? Then here 2 will be 1, here 2 will be 1, here 2 will be 1. So it will take us long time to solve this problem. Yes, it will take us time to solve this problem. It means here will be 1. Okay, as if we can make use of this part now to obtain everything. So we can we clean, since we are talking about when N is equals to 1, no more X N equals to 0. So let's consider it here. So when N is 1, it means here we're going to be Y prime 1 is equals to Z1 minus X1. It means our Y, since Y of 0.2, this implies that X1 is equals to 0.1. So here we are going to substitute in a Y prime is 1, gives us what? Supposed to make it is 1, Y prime. Okay, this is not Y prime. Let's obtain a Y prime, Y1 prime by, this is Z1. So Y1 prime is equals to Z1 is always has been given as 1. Then our X1 is what? Is 0.1. This is our X1. So 1 minus 0.1. Then the same thing applicable here. Okay, Z prime Z1 prime is equals to, look at it here, y1 plus x1. Z1 prime is equals to this one will give us y1 is 1 plus x1 is what? 0.1. So this one, Z1 prime is going to give you 0.1 will give you 1.1, isn't it? True or false? This one will give you 1.1, isn't it? Yes, that is what we are going to have. So, for the sake of time, we are going to stop here. Then in the next video, I'm going to complete everything. Please make sure you share and like this video. Thank you and God bless you.